Good afternoon, good day, good morning, whatever it is, guys. This is Mr. Morales, and I'll be explaining your review for your 9 weeks exam. So let me go ahead and I guess I'll just start into it because I cannot seem to find my copy of my notes. So here we go. Number 1, they want us to find the domain and the range of the graph that's given. So what I'm going to do is I'm going to go ahead and I'm going to identify the domain first. The domain is always measured on the x-axis. So what I'm going to do is I'll take x. My dots are solid, believe it or not. So they're going to have the less than or equal to arrow. What's the furthest to the left this graph goes? Well, that'd be right here at 0. What's the furthest to the right this graph goes? Down here at 40. So from 0 to 40 and everything in between is continuous. There's our domain. Our range is always measured on the y-axis. And since my dots were solid, I'll have the less than or equal to arrows also. What's the lowest this graph goes? Well, that'd be down here to 0. What's the highest this graph goes? That'd be up here to 800, meters, units, whatever it is, 800. So there's your domain and range. Number 2 works the exact same way. Noticing that I have solid dots, that means I have to have less than or equal to arrows for my domain. That takes away choice A because it has just the line here, but not on the second piece. So it takes away that one, it takes away that one, and takes away that already. So choice C by default is my right answer. Number 3, if v of x equals 2 times x plus 3 squared minus 62, find v of 9. So what that means is they want us to replace x with the number 9. So wherever I see an x in my equation, I'm going to plug in a number 9, and then I'm just going to do the work. So v of 9 equals 2 times 9 plus 3 is 12 squared minus 62. 12 squared is 144 minus 62. 144 times 2 is 288 minus 62. And 288 minus 62 is 226. So v with 9 plugged in equals 226. So number 4 is the same exact thing with the calculator. Now they want us to substitute in negative 9 for x. So 2 times negative 9 in parentheses squared plus 3 times negative 9 also in parentheses minus 2. Negative 9 squared is 81. So 2 times 81 minus 27 because 3 times negative 9 is negative 27 minus 2. 2 times 81 is 162 minus 27 minus 2 more. So when you do all that work and you plug in a negative 9, for x, you get f of negative 9 equals 133. Going on to the next form. Number 5, find the solution set for x squared minus 9x plus 14. X squared minus 9x plus 14. So I'm going to go ahead and graph it. Well, not graph it, factor it. What two numbers will multiply to give me a positive 14 but add up to a negative 9? Well, that would be negative 7 and negative 2. Now, to get the solutions, I would have to make each factor equal to 0. So I'll take x minus 7 equal to 0 and x minus 2 equal to 0 because we're looking for the zeros, the solutions. What number minus 7 would give me a 0? Well, that would be a positive 7. What number minus 2 would give me a 0? Well, that would be a positive 2. So my solutions are x equals positive 7 and x equals positive 2. What are the solutions for the quadratic equation 2x squared plus 3x minus 2? For this one, I'll go ahead and go to the calculator. I'm going to go ahead and clean out whatever's there, and I'm going to graph it. So let's go ahead and graph 2x squared. Actually, I can even do it a faster way. I don't have to do that. I can use menu 3 for polynomial, find the roots, and plug in my a, my b, and my c. My a is 2, my b is 3, and my c is negative 2. Okay, enter. And negative 2 and 1/2 are my solutions. Negative 2 and 1/2, choice A. Number 7, find the following pieces. The vertex. The vertex is always the lowest or the highest point, and it's a coordinate. So that would be at positive 1, negative 4. The y-intercept is anywhere your graph hits the y-axis, and that would be at 0, negative 3. My zeros are literally where the x-axis intercepts my graph. So I have two of them in this case, from left to right, -1 and +3. Notice I use the brackets and not parentheses for that one. And my axis of symmetry is the line that goes through my vertex, and that's going to be x equals +1. All right, find the y-intercept for number 8. That's wherever your graph hits the y-axis. That's right here at +5. Next 4. For these ones, write the following quadratic function in standard form. Standard form means ax squared, whoops, I didn't mean to make you dizzy there. Ax squared plus bx plus c, that means the a, the b, and the c. So let's follow PEMDAS. First, I'm going to have to multiply x plus 5 times x plus 5. Let me erase what I wrote here really quick to make some more space. So exponents come first. I'm going to do x plus 5 times x plus 5. X times x is x squared. X times 5 is 5x. 5 times x is 5x. And 5 times 5 is +25. Combining like terms, I get x squared plus 10x plus 25. Now I multiply it by the 2 that's in front, so I double everything. I get 2x squared plus 20x plus 50. Now I subtract 8 from that 50. My final answer is 2x squared plus 20x plus 42. Number 10, which of the following is equivalent to the equation 3 times x plus 2 squared minus 10? So if I take x plus 2 times x plus 2, I'm going to get x squared plus 2x, which is 4x, plus 4. Multiply that times 3, I get 3x squared plus 12x plus 12. Then I subtract 10 from the end, 3x squared plus 12x plus 2. Choice B. You can also graph this piece, and then graph each one of these pieces until you get the one that matches. And the only one that'll match will be graph B. Number 11, use the equation below to fill out the table. There's an error here. That should be squared. So 1/4 x plus 8 squared minus 5. When you do that, you get the following numbers when you graph it into a table. You get -4.5. You get -3.25. You get 56 over here. You get 92 right here. And -1.5. So make sure you put that square and then graph this. Do Control T, and then just fill in the pieces of the table. Now I'm going to work backwards. This is the regression line here. It says which function represents the same relationship as the table below. Notice all these have exponents of 2, which means if I do regression line, I'm going to have to use number 6, quadratic. That's what gives it away, because you might have tried doing it as a straight line, and none of these equations would be right. So you're going to have to plug this in and do the regression line. Now, since that's the last thing we just did, I'm not going to go through the whole process for the sake of time in this video to give you all these points. But to get the line, let's go ahead and what I think I'm going to do is I'm going to try to find the vertex first of all. Now, I can look at these points. It goes low, high, highest, low, low. The highest point is right here. There's my vertex. So the vertex, and these equations are all in vertex form, which means this is my h, this is my k. The h is whatever's in parentheses, and you have to make it the opposite, and the k is on the outside. So the k will be easy. K is +7. So which one of these has a +7 attached to it? Well, that's a -7, that's a -7, but that's a +7, and that's a +7. So we got that part, okay. Now we need the h. Now, h is always the opposite. So if my table says -2, then I need the opposite of that, which is going to be a +2, and that's this piece right here. So here's my right equation. Remember, this is vertex form. That's h, that's k. It's always the opposite over it's opposite h, normal k. You can also graph all of these and do Control T until you get the right table if you want to also. And finally, as I run out of breath, let's go ahead and graph x squared and g of x equals 4 times f of x. So here's what's going to happen. X squared is going to give you the parabola. Let me lock this down. 0, 0. -1 squared is 1. 1 squared is 1. -2 squared is 4. And 2 squared is 4. So we get this as our regular graph. When you do 4 times that, you basically are taking all the y answers and multiplying them times 4. So if I plug in a 0, 0 times 0 is 0, times 4 is still 0. When I plug in a 1, 1 squared is 1, times 4 is 4. That's here and here. When I plug in a 2, 2 squared is 4. 4 times 4 is 16, it's going to be way up here. So what I get is a really narrow, skinny graph. So when you multiply by a number bigger than 1, you get skinnier graphs. So the opposite is true over here for number 14. What's the effect of x squared when you multiply it times a fraction? Well, if a big number like 4 makes things get skinnier, then a small number like a fraction will make things get wider. Make a note of that for your test. Here we go. Number 15 is like number 12. Find the vertex of the quadratic. This is in vertex form. You take what's in parentheses right there and give me the opposite of that. Opposite of negative 6 is positive 6. Take whatever's being added or subtracted at the end, and that's your y value, positive 11. And there's your vertex at 6, positive 11. You can also graph it and get the vertex that way. And finally, find the equation with a vertex of negative 3, 7, and goes through the point 1, negative 9. So let's work on this piece first. Since the vertex is at negative 3 here, it has to be the opposite over here on the parentheses. So opposite of negative 3 is a positive 3. Positive 3, positive 3, positive 3. These go away. However, there's a negative right here, which would make it a negative 3, so that goes away too. Now I'm left with these two. I also need a positive 7. Positive 7, positive 7. So between those two, I'm going to go ahead and look at them again, and I notice that there's a negative sign here. This negative sign would make this a negative 3, and not the positive 3 that I need, so that's still a trick one. So my only right answer would be G. You could graph each one of these, and then you can see if the vertex goes through here, and then check if it goes through this point if you want to take your time. So there's the fast way to do your review. Hopefully these little tips and tricks help you for your 9 weeks exam. All right, best of luck, guys.